we can proceed.
Yep.
All right, Casper. Perfect. So I'll just give you the word then.
Yeah. Okay. Resume. Okay. So let's just clear this. Okay. So we left off trying to create this vote receive method. So we checked that the election hasn't expired. And if it has expired, we return this voting finished error here. Let's also check that only accounts can vote. So the context that sender, that is the address that sent, that tried to vote here. And that can either be an account or a contract. And then for simplicity's sake, we'll say that only accounts can vote. So if the account, yeah, so let's actually, we want to get the account address. So context the sender, again, we're matching here. So either it's, so the sender is of this type address, if I can see, of an address here. So that can either be an address account. This is also an enum. And then, so if it's an account, then we'll just return the address here and save it in this variable account. And then if it's a contract, then we don't really care about it. We just return an error, which would be, let's call it contract voter. So that's not allowed. We'll add one here. Voter, if I can spell. Okay, so here we're returning early again. Okay. So you see, this is a very Rust-like pattern. Try to get some data, and then fail if otherwise. Again, do some things and checks and fail early. That's really common. Okay, so then we want to read the voting option parameter. We've already seen how to do this. New vote. Let's say that is a voting option. Yeah, so that's current to cursor get and a question mark again, as we used before. So it returns an error. And specifically to get this to work, we added this attribute up here. You didn't see that was from the template, which converts a pass error into this pass params error. Because this actually returns a pass result, this get method, which is where the error variant is a pass error. So we're just saying that you can convert between those two, and this question mark actually also does the converting for you. So that's really nice. Yeah. Okay, so we got the new vote, and then we want to add or update vote for the account. Okay, so what is it we need to do? We need to get the, remember that I said that in the state we have the ballots that they are voting indexes into this vector of options here. So what we have to do here is to say, what is we have to say? We have to say host state dot options. And then we want to get, so this is a vector, then we want to iterate over it, and we want to get the position of some predicate. So we want to say, okay, so we're looping through each of the, like this looks a bit advanced, but it's really, really simple. Basically what we want to do is that we want to say, if we have DK, Sweden, whatever, Italy, then we want to loop through each of them and then see let's say that this up here, this was DK, or IT, Italy. So then we just loop through and see, is it DK? No. Is it SE? No. Is it IT? Ah, yes, this is the one. Well, this is the 0, first, second. Okay, this is the second position. So we just want to return 2 in this case. And in particular, it will return some too, and otherwise it will return none. So this is another enum I'll show you in a second. So we're saying that, if this matches the new vote here, then if that is the case, then we'll get position, and we'll return the position, and otherwise we'll return, is this not correct? Am I missing something? Oh, okay, let's just continue for now. Otherwise we'll return an error, invalid voting option. All right, so I hope that you are beginning to see a pattern here. Invalid voting option. Okay, so what is it where? Match on this, and then let's say that we're seeing the voting index. Okay, and we'll also convert this as a U32. It starts out as a U size, which is variable depending on platform, but we wanted to save it as a U32 because that's easier for our purposes. Okay, so that's the voting index, and then what we want to do is we want to say host.state mutable. So now we want to get a mutable reference to the state. And what we want to do is we want to look into the ballots. Remember, the ballots is a B-tree map. So a sort of map similar to like a binary tree, but a binary tree has a specific way of branching, where a B-tree map has a different kind of branching. And so something that you typically do is that you look up something in a map, and then if it's there, add something or modify. And frequently, like in other languages, these actually, like here you are traversing the map once, and then you also traverse it here again. But in Rust, you have a way of traversing it only once with this entry. So here we're saying we can we look up with the account address, and this entry actually returns like a pointer to the position in the tree where there either already is a vote or where you can add a new vote. So that's really cool that you can only traverse it once, and then it returns the correct place in the tree where you can insert or update. And then there are these helper methods. So here we have the old vote, and then we can set the old vote to be the voting index. Let's say new vote index. Let's rename it for clarity. New vote index. And then there's also this other method, or insert, and then we'll insert new vote index. Okay, so this updates the vote and the ballots. Cool. So now we actually have the voting. We have the voting receive method. The last thing we're going to add is a view receive method. It's not really special in any kind of way. It's just a view methods are frequently used for to allow other contracts to call it and then query some information about your state or your contract, and you can also use it via external tools. So here we'll create a view method. We'll modify the default parameters a little bit, and we'll return some view data here instead. Yes, and let's create a new structure with that. We're doing the same thing as before, providing these schema type, and then publish from view data. So what are we returning? Well, we'll return, let's just return the tally for now, which again will be a B-tree map, then from voting option into voting voting, let's say voting count. That's not something we have already. Count, so that's also U32. So that's how many, so that would be something like, you know, like a map where it's like DK there are 3 votes, and Italy there are 2 votes, and that sort of thing. Okay, so that's what we're returning. View data. Yes. So let's go through. Let's create a mutable variable called tally and make it a new map. This. And of course, it doesn't know, it cannot infer which types we have here, but that's okay. We'll fix that in a second. So we will loop over our ballots, so all the votes. So we will have there'll be a count and then voting index in, let's see, what is that, in host state the ballots, the iterator. Here we go. And we actually don't need the count. We just need to know the indexes. So we're basically throwing away the counts and then like summarizing on across the voting indexes. So first thing we want to get is the voting option here, which is a voting option, and we want to say host state dot options, and then we're indexing into this with the voting index as a usize. Yes, so this is, yeah, so this is just basically going, if this is 2, then we're getting, you know, whatever I wrote up here, then we're getting Italy, and if this is 1, we're getting DK, these sort of things. And then from there we can say tally dot entry again, and we can say we'll put in the voting option, and again we'll use the same and modify, so the current count there, and we'll update the current count plus equals 1, and we'll, otherwise if there's no votes for this particular voting option yet, then we'll just insert 1. And then in the end, we'll create this view data with the tally. Something is up here. Can I move? Okay. So this is something about the borrow checker again. So here I'm saying that I actually want I want voting option to own a string, which is the voting option. But I cannot just steal out the string from in here. But what we can do here is to clone, which is what we one of those tricks that I showed previously. Okay. And then the exciting moment comes where we can see whether everything compiles. So for that, we can again use here, build contract. We'll see if I didn't mess anything up. It's always interesting with live coding. And so it shows here that we have this voting contract. There's an init method and a view and a vote method. Great. And what the files that output, they live in this Concordium out folder, where there's the module that you can, it's a boss module that you can deploy to the chain, and a few other files. Okay. So that was actually how you write the smart contract. Let's just quickly go over it again, so we recall, because the next thing we're going to do is to test it. So it's pretty useful to remember what we have. So we have the state with the description and some voting options and an end time, some ballots. And then when you initialize it, you just get in the init parameter, which is everything but the ballots. And then when voting, we have these different checks, so that it hasn't expired and only accounts can vote. And then we're taking in the voting option, and then we're saving it or updating it. And then we have this view method where we are tallying up the votes and then returning it. Okay, cool. So let's get code. Here we go, testing your contract. So we're going to use the crate, which is the Rust word for packages, called Concordium smart contract testing. And it uses the exact same smart contract WASM modules that you deploy to the chain. So that's really useful that you're using not some code that is really close to the thing that will run on chain, but the exact same code. And you're also using the same WASM interpreter and engine as the Concordium nodes are using. So you get really reliable tests in terms of precision. Okay, so let's back to testing. So the tests live in here, and we already got some test code here from the template that we used, but we're not going to use that. And we can keep these constants. So what we're going to do is to write our first test. In Rust, you annotate tests with this test attribute. And that is how you tell the test runner that this is something that this is not just some function, but this is actually a test that it should run when you run cargo tests. So what we're going to do is create a chain, and this is an object or like a structure that mimics the real blockchain in your tests. So with it, you can create accounts and you can deploy contracts and update them and do various things, and then make assertions on those. And it uses a lot of the same infrastructure and code as the real Concordium nodes. So we can create some accounts. Yes, you actually need to create accounts that will pay for the transactions in here, not in the, like, they will pay in the tests. So they are test accounts in your tests that will pay. But that's also really useful to have, because then you can create really realistic tests where you can then afterwards deploy it on the chain and you can see, oh, okay, it's the costs are actually the same and all these sort of things. So it's really nice in that way. So let's create some accounts. Create accounts, account of new, and it will take an account address. We'll have Alice up here. Account addresses are just 32 bytes, and here we just use the 0 for Alice. And we'll create a different one called Bob, which account address 1. And then we'll give a balance. We can use this initial balance of CCD, which is the native current currency on Concordium. And we'll copy this and then create the Bob account as well. Okay. Then let's go over what we're going to do. We're going to load the WASM module. Then we're going to deploy the module. And then we'll init the contract. And then we'll update or vote on the contract 2 times, say. And then we'll view the tally. So this is, and make assertions. So this is what we're going to do. So the first thing is that we load the module here. So we say, call this module load v1, and then we say Concordium out module.wasm.v1, and that's this file here. And this method returns a result, and we can just unwrap here. So we cannot use the question mark here because the function itself doesn't return a result of some kind, because that's needed in order for us to use the question mark. But here we're just saying that if it doesn't return okay, then panic. You see, it panics if the value is an error. So that's good enough for now for these tests, right? Then we can deploy the module. So we'll say, then we'll use chain module deploy. And here we provide a signer, which is just for the number of signatures that go into the transaction. So it's not really, for most tests, it doesn't really matter. But if you have accounts on Concordium with multiple keys needed for signing, and you want to have your tests mimic that exactly, then you can use a signer where you have multiple keys. So it changes the cost of the transaction a little bit. And then we have the same sender, which is an account here. And then we have the was module, which is the module here. And again, we unwrap because this could fail for various reasons. But then we just want the test to fail. Then we are going to initialize this contract. So we say chain dot contract init. And again, we provide a signer and the sender, again, Alice. And then here we have to provide the energy. So since we are running programs that are Turing complete, then they might run forever or do some things that we don't expect them to. And we are actually paying, like the account is paying for the whatever it does, right? So there is this notion of energy where you can set the maximum energy it can use. It's similar to gas on Ethereum, for example. So that's that way contract, what it's called, init, payload. This formatted. Okay. And then we're giving some amount, which is CCD. And then we're giving the deployment, the module reference. And then we're giving a contract name. And here we are saying, what are we saying? It's called, it says here, the expected format is init underscore contract name. And our contract was called voting, and it expects a string. So we'll convert this. And then the parameter is an init parameter. Serial. Let's just create that. Init parameter. The reason why we have this type is because we're actually importing the voting library, like this library up here, or the smart contract. So that's quite nice. Yes, just fill these fields here. Description. Yeah, and some options. So that's okay. And these actually need to be strings as well. And then the timestamp, let's just say from minutes. So it will end in 1,000 milliseconds because it starts at 0 by default. Okay, and then yeah, we're providing in the parameter here, the init parameter, and okay, so it's a few things, but we're saying how many signatures are used for this transaction to modify the cost, and which account is initializing the contract, what is the limit of energy that we want to use, and then we can send some CCD if we want to. We're saying this is the module reference that we're using, like it's a contract from this module that we want to deploy or initialize, sorry. And in this module, there can be one or more contracts. So we're saying it's the voting contract that we want to deploy. And we have a parameter, and we're saying giving it the init parameter. And here we're serializing it. Cool. So that gives us the init. And then again, we are unwrapping. Just a test. Does that make sense? And then we want to do something similar. Actually, we want to update the contract. It looks similar from this point of view. Then we're giving the signer, and we're saying that the invoker here, that's the account that will pay for the transaction. Let's say that that's Alice. And then we can also, here, the sender can be either an account or a contract. And that's why I created this thing up here. So let's just do the same thing for Bob. Do we have a question? Sound.
Yeah, there are some questions in the comments. Somebody sent a question. So the person is asking, Mr. Casper, what purpose does the condition if 6x the sender serve in the context of allowing only contracts, not contracts to vote? You can answer me after the session. And I feel like, yeah. So I don't know if you saw that question. You can open your comment and
no, I'm not looking at the chat at the same time.
Okay, so the person is asking what purpose does the conditions if CTX or sender serve in the context of allowing only contract or not contracts to vote?
Right. Well, that was just to make the data type easier here. It's just a small simplification for this test or for this example here. And it also showcases that, you know, typically you have some checks that you do when you want to, in your contracts, right? You have some various checks and requirements. So it doesn't really matter that much. We could also have changed this to be an address here, and then it could be either accounts or contracts. But actually, there is a small issue in that. Then you can have, you know, then you can just create a number of contracts, and then there's actually an issue when you use the when we at a later point build a dep, because then we only want to have it to be accounts that can vote, because for accounts you can check that, oh, this account is from Denmark, so it's not allowed to vote for Denmark, for example. So that's also so it is actually essential in for this case.
Yeah, okay.
Yeah. Okay, any more questions before we're moving on? No. Okay. So we were, yes?
No, I was asking on the test, is it possible to make like unit test? Is it we're going to make it test for all the functions?
I'm sorry, I can't really hear you. You're very muffled. Can you write your question? Okay, if you're writing down your question, then someone can they
please just write down the question. You can go on Casper. Yeah.
Yes. Okay. So I'm moving a bit fast here, but it's also a bit of the same things that are going on here. So here we're making an update, amount 0, and the contract address that we can get from the init here, from initialization, and then the receive. We're using own receive. So the receive name is the voting, the contract name dot the receive name. And we are saying the string again here, and then the message, that is the voting option. Here, let's say dk to string here, and we're on ready. Okay, so basically this is saying that Alice is now voting for, or calling the vote in receive method and voting for Denmark. And we'll do the same thing here with Bob voting for a different country. We'll let's say that it's voting for Italy. This, and then the final thing we're doing is and the final thing we're doing is almost the same, but here we're calling, instead of making an update, we are invoking the contract, which is like simulating it. So it doesn't matter. So we won't save any results of what it's doing. Okay. Let's see, we're calling the view method, and we don't have to give any parameter. And this is the view. And then we can say, the view data is view.pass return value on Rabbit again, and then we'll do some. I think we're running a bit short on time, but then what you can do is then you can write the view data that it matches the you know, that it matches something like this, and then IT for one. I think we'll skip the rest here for now. Okay, you can view the full example in the code I've shared. Okay, so that's basically how you write your test. You create a chain, then create accounts, then you deploy the module in this test chain, and then you initialize your contract, make some updates, and then usually use a view method, and then make assertions on the code here. We're almost done here. Just needed a few more minutes. But I have to move on to setting up your wallet. So this is the next part, because we want to show how to also deploy and initialize the contract onto the chain. So you can download the Concordium wallet from this web address, from the Chrome Web Store. It works for most Chromium-based browsers. And from there, you have to create once you open it, you have to create a wallet. And here you're presented with, I think it's 24 words that are your recovery phrase, and then you have to enter them back in. And I'm not going to do that now because that takes a bit of time. But I'll show the rest live here. So let's just get out of this. So here we open up the wallet. I wonder if I can make it a bit. I can't make it larger, so you'll have to live with this. Let me just move to a. Okay, so we have our wallet, and from here we can go into our ID cards and see our different ID cards, and we can also create a new ID. And here we have a few different options, but you can also use the testnet IP identity provider, where you can create an ID without having to use your passport and these sort of things. And this is only available on our testnet and not our mainnet. From an ID, you can then create a new account. In here, for example, you can choose like identity 2. I'll use this one for creating a new account. And then with the new account, once it's finalized in a few seconds, maybe I'll switch back and forth. So this one. Now it's initialized. And then you can go in here, and then you can request some CCD because it's on testnet. So we'll just wait a second here. And then it receives some CCD here. And then what you need to do, because we're actually not going to use the wallet so much in this presentation, but we do need the Concordium client, which is our command line interface. Here you need to go into this settings field and then export private key. and then I need to enter my password, and then you can click export, which downloads the file, export data, that export. And this is what you're going to use to import in Concordium client. So next we need to install Concordium client, and that you can do from this URL. For Linux, well, the instructions are in there. And with Concordium client install, you need to run OpenTerminal and run Concordium client config account import, and then the file that we just downloaded, and give it a name for the account. And then you have access to Concordium client, to your account on Concordium client. Cool. Now let's put some contracts onto the chain. Let's just get this a bit bigger. So we'll go into the voting contract here. Bigger again. And what we're going to do is that we will say, first off, let's try to say, so we have to specify which node we're communicating with. So there's this public testnet node for Concordium that you can use. And then we can say account show. I called it web wallet, my account here. So we can see some information about it. We can see its balance and these sort of things, and its account address. But let's do something more interesting and say module deploy. So we are deploying this contract here, which lives in here. This is the Watson module that we also use for testing. We'll give it a name, and then we'll say who is the sender, which account is sending this. This is very similar to what you just did in testing, right? So we say, yeah, it sounds good. It calculated that it will use nearly 49,000 energy, and I'm entering my password, and then it's signing the transaction and sending it off to a node, and then it says waiting for committed, or already named something, already named a module voting. So now we'll call it voting 2. And then what we can do is we can say contract init voting 2. And we need to provide a parameter, a JSON parameter. And this is where we actually derive those schema types that I was talking about for the different types of structs. So I already prepared one init parameter here. I'll show you in a second what it is. Then we want to say that we are initializing. Which contract are we initializing? It's the voting contract, and we are limiting the energy to be used to 10,000. And the sender is the web wallet here. Oh, it's called parameter JSON. Okay. JSON. Here we go. And in a second, I'll show you what the parameter looks like. So it looks like this. So this is the JSON format of what we created, of the init parameter. So there's a description and some options and an end time. Okay. And then we can see that the contract got this contract index. So we can check that. So we say contract show this one, and we can see that the contract is called voting, and there's an owner and a module reference, and it has a balance, and it has some few methods like a view method, which returns a tally. And it also has a vote entry point or receive method, which takes in the string, and then it can return an error of one of these 4 kinds. Okay, so then we can say contract update, what was the 72? Yeah, 55. Just like this. So we're saying we're going to call the vote entry point. And we're giving in this vote parameter JSON saying 10,000 energy is the maximum, and it's the web wallet account that I'm using. So let's try to vote. Okay, let's see how that works. Second, okay, voting succeeded. And then we can actually, let's just see what it is that is in here. Okay, I wrote it for Denmark. Okay. Since we haven't made the depth that checks the country yet, we can vote on our own country. Then we can do contract invoke, which is also available here. Again, that's very similar to making an update, except that you won't store the results, but it's a way of calling the receive methods, but without saving any changes they made. So let's see the entry point view. Okay, and it returned a tally here. There's one person that voted for Denmark. Great. That is, can I start from here? Okay. Chain, any questions? There's a lot of silence. Should we look at any questions in here?
Yeah, okay, the chat box, somebody asked a question. He said, can you, okay, let me see. There was a question before that. I want to read it. Sorry, give me. Okay, somebody said, can you, are we going to test the entire main.rs? Is there a possibility for testing specific module function per time? That's one of the questions being asked.
Sorry, whether you can test what? The time?
Is there a possibility for testing specific module functions per time?
I'm not catching the last word, sorry. Part-time. By time?
Yes, per time. PERTIME, yes, per time. Yes.
I'm not sure what that means.
So is there a possibility for testing specific module function, like as you progress in in the writing of the smart contract? Can you do that, from time to time? From time to time. That's what it means by part time.
Yeah, I mean you can. You mean when running the tests or the writing the test code here? Is that what you mean?
So so it's asking what is the possibility of testing it, from time to time? Is there a possibility to do that?
Write all your tests up front, right? Because once you deploy it to the real blockchain, then it's harder to change, right? So you should find all the errors up front. But you might also be referring to changing the, we have this time in here, right? Is that also what you're referring to? Because you could write a test for voting not allowed after end time reached or something, and then for that you would say something like you would be able to change chain, what is it called, tick block time, and then give it a duration, so like hours, something like that, and then you could run then you can try to vote, and then see if the voting has already inits with voting ending 1 hour, and then you can tick the block time and it can vote, and then fails voting. So that's also a possibility to do something like that. But you can always run these tests, and you can also add more tests after deploying it. But of course, I would recommend always testing as much as possible before deploying it, because it's hard to change afterwards.
Okay. Another question. Can you explain the significance of the condition if CTX's metadata slot time greater than like host.state.end_time in the vote function? So let's go to the vote function.
Yeah.
Yes. So
yeah. So in here, yeah. So this this thing here. So we could make it more readable.
Yeah.
Say this. This is the current time.
Okay.
And then
save the current.
Yes, and then time like this. Because the current time is larger than the end time for the last moment that you're allowed to vote, then we will return an error, right? So it makes sense to say. I mean, this contract that I created, I decided the rules, right? But it makes sense, I thought, to say that there is a limit to how long you can vote and change your votes. So, and that's also the case in real Eurovision, right? They're doing it in one evening or something, and then you have to vote before 8 in the evening, and then that's the cutoff time. So it makes sense that if you're making a contract that does the same sort of thing, then there's a last moment where you can vote.
Okay, and a follow-up question says, what does it imply for the voting process? I think you just mentioned that, right? So
sorry,
what does this? So the follow-up, the same person asked a question that what does this function imply, or this condition imply for the voting process? I think you just mentioned it now.
Yes.
Yeah, but you can say it again.
Yeah, I mean it means that you're not allowed to vote after a certain time that we specified when we
in the beginning.
Yeah.
So let me check. I don't think there's any other question. If there are any, okay, this is time to ask a question. Please, if you have a question, you can do it. Just unmute yourself, and let's ask your question.
Okay. I actually have a question.
Yeah.
You could go ahead, sir.
Okay, so if you go to the tests, there's a parameter that you wrote energy reserved, and I just want to know what it means and how it's actually quantified. That's my question.
Sorry, which parameter?
The energy reserved, like on the init, the contract init, there is an energy reserved parameter that you wrote energy from. Yeah.
Yeah. Here.
Like on line, I think 42, on line 42. Okay, line 41 actually.
Yeah, the energy.
Yeah, line 41. So what does it mean? Like the energy reserved, what does it mean? And
so it's like, do you know gas?
Oh, gas. Oh, okay. Thank you.
Yes. So on Concordium, we have this notion of energy. So you could write a contract that that just does loops forever. This is how you write a loop. That loops. Or is it like this? Something that loops forever in Rust. So if you called, print, right? So if you called this vote receive method right now, it would just loop forever. And then, so if I'm calling it and hoping that, okay, I'll spend, that's fine. I'll spend, $1 or whatever it is, on voting for this election. And then actually it just runs for a very long time, and I have to pay for all of it. And suddenly it costs, $1,000 for where I just try to vote on this contract, right? That's not very nice. So I specify, whenever I call a contract, I specify this is the maximum amount of energy you can use, which is the same as gas on other chains.
Okay, thank you. Another question on line 28 of the test. What actually is the difference between the signer and the sender?
So the signer is just a, well, you can see the whole, this is a signer. It's just a structure holding a number. So the signer is only, it is a bit
like a nonce?
Little bit confusing, yes, but it's because you can, this actually maybe it makes more sense too. If we can actually look up here in here, we can say we can check the balance of Alice in here by checking the chain dot, let's call it account balance available, and then Alice here. And we can check the balance here. So let's say it's, you know, maybe it's like this much or something. And that's the balance is this number now because it's we started out with, how much did we start out? We started out with 10,000, and then when Alice deployed the module, something was subtracted, and the amount and every transaction that the Alice account does subtract some CCD from it. I mean, these are just during the test, right? But actually, if you change the so the signer here defines how many like virtual keys you're using to sign the transaction. In the real, like when using Concordium client, I just used one key to sign the transaction. But you can actually add multiple keys to your account and say that, you know, 3 out of 5 of these keys can need to sign the transaction before it's valid, and then you can hand out, you know, the keys to you know, your family members or something, and then you all need to agree and sign before it works. So this signer just represents how many keys were used to sign this particular transaction, and it's only there because the number of keys that are used actually affects the cost. So if we use like a, you know, 100 keys, maybe this would be, you know, a little bit less down here of the balance of Alice, because you use more keys to sign all the transactions up here. Whereas the sender that's just saying this is the account that has to pay for it. And what is it paying for? It's paying for based on, like for the deployment here, it's paying based on how big this WASP module is, and then also how many signers that are used. Did that answer your question?
Yeah, actually it does. Thank you.
Thank you very much for that. So I'll be dropping, okay, I already see some questions like, oh, create a Discord server. Oh yeah, we'll be dropping our Telegram channel for Tech Fiesta. And we can have, what do you call it? We can have you come and ask a question. I know Bogachan, and will be, I think he's in the community, so you can always ask a question in the community and get the necessary answers. Any other question? If you have any other question, you can unmute yourself. I'm checking the comments now. I don't think I can see any question. So let me just drop it here.
Yeah. And as I just showed, notice that at the developer Concordium software, you can find all our documentation. So like build on Concordium, you can see a lot of.
Sorry, someone mentioned something now. I'm sorry.
Yeah, that's
Casper.
fine.
Somebody said they have a question on signers. So can you say something about signers? The
signer again?
Yeah.
Okay, so let's so the signer is just you shouldn't really think that much about it, I would say, But the assigner is just, as you can see here, it's really just which is something like this, number of keys. It's really just, this is what the whole assigner is. It's a symbol struct with a number of keys, and then this number, and then someone's stealing now. And then this number affects the transaction cost because it mimics the number of signers used per transaction. So yeah, so for this, let's say that this transaction 1 is Alice, and then deploying the module there, and then the signer is one key. Then maybe that costs, I don't know, 123 CCD, and then transaction 2 is nearly the same, Alice and the module, and then the signer, but then we say 3 keys are used. Then maybe the cost is 127 or 27 CCD. So it just affects the price of the transaction, and in turn affects the balance of the account.
Okay, so, I'm sorry to cut you in, but I think I have a question on this right now. So when you say a signer is like 1 key or 3 keys, and what next? Do you have to like pass the private keys of these signers, or what else? You just say it's 2 keys and you move on with that?
So this is in the testing library here. We don't use any keys because everything is like local on your computer and it's not on a blockchain. We're just simulating these things so you can test that your code is doing the correct thing. But the signer represents when it has 3 keys, it really just means that there's this structure, there's a 3 written in here, and it just changes the cost of the transaction a little bit in your test. So you don't need to use any private keys or anything in here, but because this is just for testing. But it represents this, you want to be able to mimic the exact behavior that occurs on chain, and that's why you have this signer.
Okay, but in real life, you would have to pass a private key. Is that it?
Yes, in the real life, you for example, when I ran the commands in the terminal with Concordium client, then it uses my private key where I have to unlock it with a password.
Okay, thank you so much.
Yeah, sure.
Yeah, thank you very much for that, Caspar. So somebody asked a question. I think I almost missed that. Going back to the question, quite long. So person says, Caspar, when working with lifetimes in Rust, how would you design a function that accepts a reference to a struct and returns a reference to a field within that struct, ensuring the lifetime annotations are correctly handled? And can you please provide a code snippet illustrating your approach and explaining the reasoning behind your choices of lifetimes?
Yeah, sure. Yeah, so something we didn't talk so much about is lifetimes, but that is related to, if you recall the first example that I showed with things going in and out of scope. So let's create a function here, something, let's call it something, and let's say again that it's now gets the state. Then we wanted to return something. What could we do? We could say, okay, let's create a function called count votes. Create tally. That seems, so that takes in a the ballots, and that is the ballots is, what was it? It was a B-tree map from account address to voting index, and then it returns the B-tree map from voting option to voting count, right? So this is, so it takes the ballot and then returns the tally. But here it takes a reference to it. You know, it does some things in here. So for this, we could do like a extract ballot. I mean, it's a very artificial thing, but you know, we can have the state here. Then it returns the ballot here. And then you could say something like the ballot here is extract ballot. I mean, it's very, but state, and then the tally would be create tally, and then you could give in the ballot that we just created. And here the lifetimes are actually hidden because that's, for a lot of things, that just makes more sense. And it's easier to read, but lifetimes, you can see them here. So this means that, so you can see here that we have a lifetime for this reference called A. So these are implicit in most cases. But you could also make, yeah, in other cases, like if there are more parameters, then there might be different and there might be different lifetimes for these. Explain my reasoning behind it. I mean, in a lot of cases, it's just about getting it to work, right? And the lifetimes are really there to sort of make the whole thing work without you having to free your memory. Yeah, they can be a little bit tricky to work with initially, but in a lot of cases, you don't actually have to worry about them, and that's also the case for a lot of smart contracts because they're very simple. But this sort of illustrates what the lifetimes look like underneath, which are usually omitted. Yeah, I hope this sort of answered your question. Otherwise, feel free to ask more questions.
Yep. Thank you very much, Casper, for that. I hope that answered your question. If not, you can do well to unmute yourself. I think Daniel. Oh, Casper already touched it. Okay, fine. Thank you so much. So yeah, for everyone asking about the where they could continue their conversation, please, I dropped the Telegram channel link. Do well to join the Telegram channel, and that is because immediately after this session, the developer challenge is going to be starting. So I don't know if Casper, do you have any last words? Boga-chan has any last words? So we can just announce, the start of the developer challenge, and I can drop the links for that so that people can start, engaging the developer challenge.
Yeah, sure. I mean, the only thing is the that website that I showed, like developer Concordium.software. That's really the place for more materials. Yeah, you can find all the things there, depths examples and smart contracts examples and these sort of things, and build on Concordium. That's the place to go. Yeah, that's it.
Okay. Thank you very, very much, Bogachan, for that. So a quick one, guys.
I would,
Theo.
Guys, I would just like to finish up as well a little bit from more use case side, right? I mean, we learned a lot thanks to Casper about all the developments and all the things that, all the ideas that this introduction might have sparked in you. Please reach out to all the developers out there, to everybody who got curious about Concordium and is currently working on a project, maybe somewhere else or on another chain. If you are interested in understanding more about our ecosystem and understanding more about what you can do, please reach out to us at the projects@concordium.com. You can always as well find more contact details on our website, concordium.com. And yeah, we are super happy as well in assisting projects and use cases in developing and integrating with our ecosystem. We also have a grant program live where we support projects as well from a technical but also from a financial perspective to cover their integration or on-chain development costs to a certain extent. So if you have use cases that you think fit perfect or where the Concordium technology fits well, to please reach out to us. And yeah, we're just looking forward to hear from you.
Thank you, everybody, for the participation. And yeah, see you next time.
Okay, before we all leave, thank you very much. So, like I said, a developer challenge is going to follow this training. We are done with the training. It was an intensive training. Personally, I learned a lot, and I'm also going to be going through the recordings. So the recordings should be available within 24 hours. That means by this time tomorrow, surely the recording should be available. It wouldn't get to 24 hours, but I'm just saying within that time frame. And just so you know, like I said, 2 important information. I posted the Telegram channel link, which is TechFiesta Telegram channel, which is important to join. That way you can always ask questions, even about the developer challenge. So the Prosper, one of my teammates, already dropped the developer challenge link. So go there to the developer challenge page and answer what do you call it? Oh no, they are all recordings of other hackathons have been are available on our YouTube. Go check the YouTube. ToroNet, every one of them are available. So yeah, I'll talk about that in the Telegram channel, Daniel. Thank you very much. So join the challenge by just clicking on that link. We already have a tax for you. There's a price for every valid submission for the top valid submission, right? So go to the landing page. Participate now. If you have any question, please, like I said, join the Telegram channel. That is the channel where you can ask the question. I think I should just make that post again because it's always important. So you're not just lost. You can always have, community of people to talk to and also community of people to, ask questions. So please join the Telegram channel.